morning. So today the class is about optical rotation, optical activity and specific rotation. Okay, optical activity is nothing but when a polarized light is incidenting on a crystal. Okay, when a polarized light, if we incident on a crystal, then the plane of polarization will not same as the incident polarized light. Means there is a difference in the incident light and the plane of polarization. So this is done through a rotation of a crystal. So this is known as this phenomenon is known as optical activity. Okay, so the materials which produces the optical activity is known as optical active substances. Now let us main focus on the definition that what is an optical activity. Means when a polarized light is incidenting on a crystal, then the plane of polarization will be different from the incident polarized light. So this phenomenon is exhibited by some special crystals is known as optical active substances, and that phenomenon is known as optical activity. So the examples for the optical activity is quartz. So quartz can produce optical activity, and sodium chlorate, cinnabar and sugar crystals. Okay, then the optical activity depends upon the thickness of the crystal and the density or the concentration of the crystal and the temperature of the crystal, and mainly the wavelength of the incident light. Okay, now the optical active substances are of two types. One is Dextro Rotatory and Rotatory. I said the optical activity of a substance shows this phenomenon through a rotation. So if the plane of polarization rotated in a clockwise direction, okay, if a plane of polarization rotated in a clockwise direction, then it is known as Dextro Rotatory. That is means right-handed rotatory. For suppose if the plane of polarization rotated somewhat towards the anti-clockwise direction, then it is known as rotatory. So this is the theme of the optical activity. Now next, the specific rotation. What is the specific rotation? Means the optical activity for a substance is measured by the specific rotation of its substance. It is also known as specific rotatory power. So specific rotation is nothing but it measures the optical activity of a substance. Okay, so now the specific rotation of a substance for any given wavelength at a given temperature is defined as the rotation produced by a 1 path of decimeter. Okay, the rotation produced by a 1 path of decimeter. So the 1 decimeter is nothing but 10 centimeters. Okay, so according to the formula, mathematical form of the specific rotation is expressed in the term of alpha. Now the alpha is equal to theta by L by 10 into C. Theta represent rotated in degrees, okay, rotation, and L is the length or the path followed through the rotation, and C is the concentration of the material, density of the material, optical activity substance. Now L by 10 extend to the numerator, 10 theta by LC. Okay, theta is the measure of degree. Okay, now the units of specific rotation is theta is nothing but degree, and the L is, we took the length as 10 centimeters, that is 1 decimeter. So here it is in decimeters. So L inverse, nothing but decimeter inverse by, what is the concentration unit? Gram per centimeter cube inverse. So this is the specific rotatory power or specific rotation. So completely today's class is about optical activity as well as specific rotation. Thank you.